Okay, more about vectors. We were just talking about unit vectors, I and j in 2 dimensions. I is equal to 1 and 0, and basically it's talking about, here's I right here, if this is 1, and it's talking about directions in what we would call the x-axis. J is equal to 0 and 1, and here is j, and there is 1, and it's talking about going up and down what we would call the y-axis. Okay? So let us, once again, use our very good friend vector u, which is AB, and let's see what we can figure out some stuff about here. So here is the point AB in the plane. This would look like the vector, and now let's do this. Okay, so clearly this should be the point, okay, this is the point A and 0, this is the point 0 and B. What's the relationship? And let's do this. This is the norm of the vector. And remember, the norm of the vector is going to be a squared plus b squared square root, your basic Pythagorean thing. What's the relationship? All the relationships here. Here's some angle theta. This is a right angle. Well, let's take a look here. So cosine of this theta is going to be, so here's your length A, is A over this norm of V, right? So A is equal to the norm of V times cosine theta. Similarly, B, and I ran out of room, and I need a new color. We got green ones. B is this chunk here. Thopefully it's clear that since sine theta equals B, that B is equal to the norm of V sine theta. Okay. Now I'm going to do some problems for you guys. These are just like the ones that you're going to be assigned. It says P is some point, Q is some point, find the norm of the vector PQ. Okay, so this is really kind of low grade stuff. I mean, I hope you think this is easy. If you have Star Trek playing in the background, go ahead and turn it up. It's a Star Trek marathon today here. If you're lucky, there is one today there. Or maybe Dark Angel or something like that. But anyway, I'm not even going to draw a picture of it. It's just too easy. It says the point P in the coordinate plane is the point 2 and 3, and the point Q is 5 and 9. They want us to find the norm of PQ. Okay, so first, how do we even find the vector PQ? Well, so this is the typical thing that we're doing. Actually, maybe I will draw a picture. So the point P is 2 and 3. 1, 2, 1, 2, 3. So here's my P. The point Q is 5 and 9. Let's see, 1, 2, 3, 4, 5. 3, oops, it'll have to be bigger. 3, 4, 5, 6, 7, 8, 9. Now we try and make this look something like it's right. Here's the point Q. Okay, so here is the vector. Oopsie, ouch. Here is the vector PQ. And this is what they mean. What's the norm of this? The norm is this length, and we already know. How do you find the length of this? We use the Pythagorean theorem, right? So this point is what? 5, 9. This point is 2, 3. This is just the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to let this be x2 and y2, x1, y1. Incidentally, would the answer be different if I let this be x2, y2, and this x1, y1? No, the square kills off the difference. So, however, this would be more typical of how you'd see somebody like me doing this. So this is going to be the distance, or the norm, which is what we're looking for, is going to be 5 minus 2 squared, I ran out of room here, plus 9 minus 3 squared, square root. This is 3 squared, which is 9, plus 6 squared, which is 36. This is the square root of 45 on a good day. It would be bad if you left it like this because this is the square root of 9 times 5, which is 3 times the square root of 5. And where did I go with this? Where did my piece of paper go? Oh, yeah, duh. Okay, so this is it, right? What's your next problem? Okay, problem like you're going to have to do. It says find a vector with the origin as an initial point that is equivalent to P and Q. So that what they do is they say P is the point 1 and 5, and Q is 7 and 11. Let's see what they're really talking about here. And if you can really understand this, this is going to be great. And the reason I drew such a big picture is I'm going to try and make this really clear. The vector P, Q, we find by, okay, so we find the point 1 and 5, which is here, and this is P. And then Q is 7 and 11. This is 1, 2, 3, 4, 5, 6, 7. And 11 would be about right here. So with any luck, this is actually drawn somewhat correctly. So here is this vector right here. This is PQ. They want us to find a vector. They basically want us to translate this down to this place right here and figure out how to do this. But this can actually be made a little more simple if we already think of these as vectors from the origin. There's no reason why I can't just think of this P as a vector itself, right? I can, instead of thinking of it as a point, I can let this be a vector and let Q be a vector, 7, 11. Okay, so this is, let me get another color. So here is the vector. Oh, I got it. Drawing straight is hard. Oh, okay, so here is the vector Q, if I'm thinking it like this, right? So here's this vector PQ that's up in the plane by thinking about these as points. Here is a vector P, and here's a vector Q. What I'm really looking for is, and I'll try and draw this right. Ooh, you know what, that's not too bad. I'm looking for the translated vector, and they wanted me to call it OR or something like that. Oh yeah, OR for origin, duh. Right? This got moved here, but think about, what is this? Remember vector addition, when you add a vector, if I want to take this vector and this vector, I take them, stack them up, and then I draw a line between. If I want to subtract vectors, if I wanted this vector minus this vector, I would take this vector, because it's minus, I would turn it around here and point it down this way, and hopefully you can see, oh, that's just not really pretty. Let me do it again. So what I've done is, I've said I'm taking this vector and I'm subtracting this vector. To do that, I would do this as I showed before, and this would be the point that you would draw it to. And you'll notice that's exactly what we're looking for. So if I'm calling, I only have a minute left, if I'm calling the vector Q 7, 11, and the vector P 1 and 5, the vector OR is going to be Q, the vector Q minus the vector P, and this is the vector 6, 6. Actually, yeah, 6, 6. So we got to go, and I guess what I'm going to do is come back here and do more of these, but basically this is how this construct worked out. And I bet you're more confused because sometimes I just don't explain things very well. I'm going to come back tomorrow. I'll pick this up. Absorb, absorb.